Are security problems that happen, open quote, deep inside the system at hardware, operating system, memory, or CPU level, close quote. Not at website level, login form level, API level, but inside memory, processor, operating system, firmware. Simple definition. Low-level weakness equals to a vulnerability that exists in the foundation of a system, hardware or core software. If foundation is weak, everything above it is at risk. Simple real-life example. Imagine you build a strong house, but the ground foundation is weak. Even if walls are strong, the whole house can collapse. Low-level weakness, weak foundation. Where do low-level weaknesses exist? CPU, RAM, memory, operating system, kernel device drivers, firmware. Embedded systems, common types of low-level weaknesses. Matchel buffer overflow. We discussed this earlier. Happens when program writes more data than memory can hold, overwrites nearby memory. Leads to crashes, code execution, system takeover. Sharp memory corruption. Program accesses invalid memory, freed memory, out-of-bounds memory. Can cause privilege escalation, remote code execution. Race condition, kernel level. If operating system fails to handle timing correctly, attackers can gain higher privileges. Hardware level bugs. Example, Microsoft Windows kernel vulnerabilities, CPU flaws like Spectre. These affect entire system. Firmware weakness. Firmware runs before operating system. Example, BIOS, router firmware. If firmware is vulnerable, attacker can control device even before OS starts. Real-world examples. Example 1, Spectre and Meltdown affected CPUs from Intel AMD. This was not a website bug, it was a CPU design weakness. Impact, memory leakage, affected millions of devices, required OS patches worldwide. This is low-level weakness. Example 2, WannaCry SMB exploit. Targeted vulnerability in Microsoft Windows. It exploited low-level memory bug in SMB protocol. Result? Remote code execution. Ransomware spread globally. Hospitals, banks, companies affected. Had example 3, Dirty Cow Linux kernel bug. A famous Linux kernel vulnerability. It allowed normal user to gain root access. It exploited a race condition in memory management. Very low level inside kernel. Why low-level weaknesses are dangerous? Because they affect entire system, bypass application security, allow privilege escalation, hard to detect, often require patching OS or hardware. Why they happen? Mostly due to unsafe languages, C, C++, complex system design, performance optimization, hardware design flaws. Low-level code is very complex and sensitive. Difference. High-level versus low-level weakness, high-level, low-level, XSS, buffer overflow, SQL injection, kernel exploit, IDOR, CPU vulnerability, logic bug, firmware exploit, high-level, web app layer, low-level, system foundation. Who exploits low-level weaknesses? Advanced attackers, nation-state hackers, malware developers, ransomware groups, because exploitation is more complex. Final simple understanding, low-level weakness equals a vulnerability in core system components like memory, CPU, kernel, firmware. It is deeper than website bugs. If exploited, whole system can be compromised. If you want next, I can explain kernel exploitation basics, simple, firmware hacking basics, how OS protections work, ASLR, D explained simply, difference between user mode and kernel mode. Tell me what you